that I'm going to discuss today is the Kendall'S coefficient of concordance, W. Kendall'S W is a non-parametric statistic. It is a normalization of the statistic of the Friedman test. It is used to find out if there is an agreement or concordance among raters or judges of n objects or individuals. The interpretation of the value of W is high agreement when W is equal to 1 and no agreement when W is equal to 0. Suppose, for instance, that a number of people have been asked to rank a list of political concerns from most important to least important. Kendall'S W can be calculated from this data. If the test statistic W is 1, then all the survey respondents have been unanimous and each respondent has assigned the same order to the list of concerns. If W is 0, then there is no overall trend of agreement among the respondents and the responses may be regarded as essentially random. Intermediate values of W indicate a greater or lesser degree of unanimity among the various responses. While tests using standard Pearson correlation coefficient assume normally distributed values and compare two sequences of outcomes at the same time, Kendall'S W makes no assumptions regarding the nature of the probability distribution and can handle any number of distinct outcomes. The formula that we'll be using for Kendall'S W is W is equal to 12 times the summation of D squared divided by M squared times N squared minus 1, where W is the coefficient of concordance, D is the difference between the individual sum of ranks of the raters or judges and the average of the sum of ranks of the objects or individuals. Summation of D squared is the sum of the squares of the difference. M is the number of judges or raters and N is the number of objects or individuals being rated or ranked. For the significance test, in the case of complete ranks, a commonly used significance test for W against a null hypothesis of no agreement is chi-square is equal to M times N minus 1 times W, where of course test statistic takes a chi-square distribution with degrees of freedom is equal to N minus 1. For our example problem, we have here a data on the ranking of 10 projects done by 4 judges. So, for the problem statement, is there an agreement or concordance among 4 judges regarding the 10 projects? For our hypothesis, for the null, there is no agreement or concordance among the 4 judges regarding the 10 projects. For our alternate, there is an agreement or concordance among the 4 judges regarding the 10 projects. For the level of significance, we will be testing this at alpha is equal to 0.05. For the degrees of freedom, we have there n minus 1, we have 10 minus 1, which is equal to 9. For our tabular value, chi-square at 0.05 with 9 degrees of freedom, we have 16.92. For the statistic, we have there W, coefficient of concordance, or you can simply write Kendall'S W. For our computation, okay, we have here our 10 projects and the ratings of our, or rankings of our judges. The first thing to do is to add the ranks of the 4 judges A, B, C, and D of the 10 individual projects and then place them under the column of the sum of ranks. As you can see, we have here 1 plus 2 plus 3 plus 4, we have there 10. 3 plus 1 plus 2 plus 2, we have there 8, and so on. Then, next is to get the summation of the sum of ranks, which is denoted by summation of R. We have a total of 220. The next is to get the average or the mean. We have there R bar is equal to 220 divided by 10. It gives us 22. The next is this average of 22. We need to get the difference or subtract it from the sum of ranks. We have there the difference between 22 and 10 is 12. The difference between 22 and 8, we have there 14. The difference between 22 and 12, we have there 10, and so on. Okay? Then the next thing to do is to square it. Okay? Get the square of the difference. We have there 12 squared, that is 144. 14 squared, we have there 196. 10 squared, we have there 100, and so on. Then, after that, we need to get the summation of d squared, and that is 1048. Okay, so next is to get the value of our W. So we'll be using the formula W is equal to 12 times the summation of d squared divided by m squared times n squared minus 1. We have here W is equal to 12 times 1048 times 4 squared times 10 squared, which is 100, minus 1. It gives us 0.79. Then for the test of significance, we have here chi-square is equal to m times n minus 1 times W. We have 4 times 10 minus 1 times 0.79. It gives us a computed value of 28.44. Next is the decision rule. If the computed value is greater than the tabular value, reject the null hypothesis. For our conclusion, since the computed value of chi-square, which is 28.44, is greater than the tabular value of chi-square, which is 16.92 at 0.05 level of significance with 9 degrees of freedom, we reject the null hypothesis. That means that there is an agreement or concordance in the ranking of judges regarding the 10 projects. Okay, that's all. Thank you and God bless.